Hello, and welcome to this recorded learning on the ChipScope Pro Software. My name is Frank Nelson. I'll be your instructor for this module. In this module, we will learn about the in-circuit verification capabilities of the ChipScope Pro tools. This module also has VHDL and Verilog versions of two labs that you can complete that will enable you to use ChipScope Pro tools quickly. If you are an experienced ASIC designer or new to FPGA design, this module will help you reduce your learning curve and get productive faster with your new FPGA design. This module will help you debug and verify the functionality of your design. The practices covered here promote fast and efficient debugging. The objectives of this module are to get you up to speed on the basics of using the ChipScope Pro software. That includes being able to describe how the ChipScope Pro software works, but also the benefits of using ChipScope. We will describe the ChipScope cores that are available and how to use the ChipScope core generator and the core inserter tools. It will also be helpful to you if you can plan to use ChipScope early in your design flow. This will enable you to plan for sufficient resources to be available for debugging your design. But first, we're going to discuss the importance of being able to perform on-chip debugging of your hardware design with ChipScope Pro software. Well, as we know, FPGA designs are becoming larger and more complex. Designs are running at a higher speed, and designers have less time to design, simulate, and debug their FPGA hardware. In fact, a recent FPGA design survey indicated that debugging and verification accounted for nearly half of the entire design time. As design speeds and size have increased, debugging and verification has become more challenging. To help improve design time, Xilinx recommends the use of its ChipScope Pro software. This enables die-level testing of a design by applying stimulus to internal nodes of a design and then retrieving the resulting signals using the ChipScope cores built with FPGA resources. To do in-circuit verification with ChipScope, you will apply stimulus to many nodes in the FPGA and store the generated signals using FPGA block RAM as well as other logic resources inside the FPGA. The generated results can then be displayed with a ChipScope Pro logic analyzer. This allows you to quickly verify the operation of many nodes and verify the operation of your device in circuit. Electronic debugging involves probing a design to determine what is happening on the chip at the die level. To do this, the ChipScope cores are placed inside the FPGA and be connected to the nodes the user wants to test and verify. This enables a user to test portions of a design independently, then verify the design's functionality in an iterative fashion so the user can break the design down into several major components, test the various inputs and output signals of each component, and finally decide about making any design changes. The design can then be changed, resynthesized, and re-implemented before the FPGA is then reprogrammed. This iterative debug process is possible because of the reconfigurable nature of the FPGA. This speeds the entire design verification process and gives the engineer a great deal of confidence that his design is operating properly and reliably. The ChipScope Pro software makes debugging easy since it allows users to test parts of a design and enables a fast iterative process. This can reduce your overall design time by 25% and reduce on-chip verification and debug time by half. Since ChipScope uses FPGA resources in its component construction and verifies functionality at the die level, there isn't any extraneous delay inserted into a sample path. This removes the unnecessary timing variation when you debug with oscilloscopes or other logic analyzer solutions. ChipScope software is also tightly integrated into the Xilinx FPGA design flow and offers specialized flows that support all of Xilinx's customers. This includes optimized cores for DSP as well as embedded design. So ChipScope is a powerful tool that is also easy to use and tightly integrated. As I mentioned, Xilinx offers some tailored debugging cores for DSP and embedded applications. This saves you time and effort to customize the cores for standard bus applications, for example. The standard debugging cores, which we will describe in just a few moments, support debugging any FPGA design. These cores will have to be added to your FPGA design, and that means you will have to save some FPGA resources for debugging purposes. This explains what we meant by plan for debugging. These cores are made by the Xilinx software and allow for minimal resource usage, thus saving die resources for your design. These cores can be added to your design a couple of different ways. We will discuss how they are added in a moment. After adding the cores, you'll apply stimulus and sample internal nodes. The sampled signals are then stored using FPGA block RAM and retrieved using the ChipScope software with the dedicated JTAG chain. JTAG is used to communicate with the ChipScope cores, so no additional pins beyond the JTAG pins are necessary for debugging. The internal signals are then displayed with the ChipScope logic analyzer. This slide shows the debugging cores that may be required for debugging your design. The VIO core, or Virtual Input-Output core, is used to apply stimulus and read output transitions on nodes that you have selected. You can think of this core as a virtual test header that can be placed on any node in your design. The ILA core, or Integrated Logic Analyzer core, is a capture core. It can be used to create custom triggers that, when activated, cause the storing of data during circuit operation. These conditions are placed by you to control when your system signals will be stored. Your sampled signals are then encoded in your FPGA's block RAM for later retrieval via JTAG. The ILA core allows the user to customize the width and trigger ports so that different sizes of data can be retrieved. The ILA core is a basic core used in most HDL designs. The IBA, or Integrated Bus Analyzer core, is optimized for embedded designs that is used for building designs using the Xilinx Microblaze Soft Processor core or a dedicated PowerPC core. The IBA core allows the designer to analyze PLB and OPB bus signals and offers protocol detection, which is necessary since embedded designers are often testing their custom peripherals using ChipScope. ChipScope makes it easy to sample the most commonly sampled signals on these buses, such as control, address, and data signals associated with these buses. The Agilent Trace Core 2 is commonly called the ATC2 core. This core is useful for storing larger amounts of data off-chip or when a customer is using the Agilent Trace Port Analyzer. It offers on-chip debugging of Xilinx FPGAs with the Agilent FPGA Dynamic Probing feature. The ChipScope cores use FPGA logic resources in their construction, of course. Block RAM and slice resources are used for storing trigger conditions and data. The FPGA slice resources can also be used for comparing the internal signals with your trigger conditions. The ChipScope cores will require a significant amount of resources, so you'll have to plan on leaving room for them in your FPGA. This sometimes means that users have to use a larger part for testing and prototyping, and then use a smaller part in the same package for production. To help with planning sufficient resources for debugging, the ChipScope Pro software has a built-in resource estimator as part of the core generator and core inserter tools. This makes it easier for you to plan your debugging as part of the design construction.